All right, math people, today we're going to go over the different sets of numbers and how to classify them. This goes along with my Intro to Math Practice 1 page. So we're first going to start off with our natural numbers. The natural numbers are the counting numbers, 1, 2, 3, 4, and so on. And they're denoted with an N, kind of a funny looking N. After that, we have the whole numbers, and with those we add on a 0. So 0 kind of looks like a donut, and donuts have holes. So that's 0, 1, 2, 3, 4, and so on. And those are symbolized by a W. And after that, we come across the integers. Now, if we take the whole numbers and we take their opposites, we will get the integers, like -1, -2, -3, and so on, going back. And of course, the integers includes the wholes, which includes the naturals. The integers are denoted with this Z. And if we start dividing, taking fractions, using the integers, we'll come across the rational numbers. A rational number can be written as a fraction that has integers in the numerator and denominator, or it can be written as a decimal that either stops or repeats. So a decimal that stops like 0.25, or a decimal that repeats like 0.3333, so on, which we could just write with a bar going over it. And those are denoted with this Q for rational. I guess Q stands for quotient. If it's not rational, then it's irrational. Irrational numbers cannot be written as fractions. So you cannot write as a fraction using the integers. And the decimals here do not repeat, and they never end. So no repeat, no end. Like pi. And no end. So pi, usually we say pi is approximately equal to 3.14, but you should know that it goes on and on and on. It doesn't repeat itself. And other numbers like square roots that don't come out to be a nice fraction or decimal. Cube roots, other numbers like e. Anything that can be written as a decimal that doesn't repeat and it doesn't end is irrational. The irrationals and the rationals together make the reals. And we have this, again, Venn diagram, so we should think of these kind of like as nested dolls, like those Russian dolls, where you have one inside the other, inside the other. So the naturals are inside the whole, the wholes are inside the integers are inside the rationals, and the rationals are inside the reals, along with the irrationals. They're also in the reals. There's other sets out there, but those are the ones that we're going to deal with in this course. So here is the first part from practice 1, and we're going to just name the set or sets to which the number belongs. So there's more than one answer. The first one is 6. Where do we first come across a 6? Well, it would be in this list right here. So it is a natural, and that means it's also a whole number. Whole numbers are integers, and we can write it as a fraction, 6 over 1, so it makes it a rational number, and all of those are real. The next one is -6. -6, the first time we would see that is in the integer list. And if it's an integer, then it must also be a rational number, and if it's rational, then it must also be a real number. 4/5 is the first time we see 4/5 would be up here with the fractions. 4/5 is a rational number, and it's also a real number. The square root of 53, that's not anywhere here on the left side. We would only see that in the irrationals. And I'm going to abbreviate it like that. There's no strict abbreviation for irrational. And it is also a real number. 0, where's the first time a 0 pops up? Well, sometimes some people might count it as a natural, but for me, I'm putting it up here in the wholes. And then it's also an integer, and it's also rational, and it is real. 3 is similar to 6, right? So that's also a natural, a whole, an integer, a rational, and a real. 20 over 13, that's a fraction, the same as number 3, so that's going to be rational and real. Pi, where does pi belong? Pi, again, is not just 3.14, it's a decimal that never repeats and never stops. So pi is irrational and real. 9 is a counting number, so the first place we find that is the naturals and the wholes and the integers and rational and real. And then -1 is a negative number, just like -6. So that makes it an integer, a rational, and a real. And I think you get the idea. The fraction here, any fractions are rational, they're real. And square roots and cube roots and stuff that don't come out to be even are irrational, and they are real. So I hope that helps with the first practice exercise of Intro to Math. Have a great day. We'll see you. Bye.